basic example I want to discuss about. um, this hash include register 51 dot h 50. This is include, this is why we using register 51, why we including register 51 dash, because register 51 library having all the SFR register addresses and every 8051 internal addresses we have in register 51.h. And this hash include standard input output.h. It is also not required in many times. S bit is used to set the particular pin. Port 1 is the bit addressable register, so I'm using only port 1.0 pin, so that is the reason I set as a S bit PWM equal to port 1.0. If you want to use the total port 1 register, you can use as SFR directly. SFR is used to set the 8-bit register. If you want individual bits you want to set, you can use S bit, and this is the function we are defining, why timer 0 delay. And why, because we are using here that. And while one, this loop will infinitely continuously run infinite time. And first VWM equal to 0, that means port 1.0 equal to, I set as a 0. Actually it is a high, so I'm pulling down to low. And after that timer 0 delay, it is 100, and it goes to the header here, chars x equal to 100. For x, this is also for loop. It will run up to 100 times only. And tmod equal to 1. Tmod equal to 1 means 000 hexadecimal 1, 0 0 0 1. And ts0 equal to 0 d8, and tl0 equal to, we are using as a 5536 values to count up. Sorry, we are loading as a 55,536 to count up to 65,536, so that we can get 10,000 counts. 10,000 into, we are using as a 12 megahertz clock frequency, so we get 1 microsecond to take each count. And 10,000 into 1 microsecond, it will generate around 10 10 milliseconds. So 10 milliseconds, and this loop will rotate it to 100 times. That means 100 into 10, it will generate 1 second delay. After that, this bit is a timer 0 equal to 1, then timer will start counting up from 55,536 to 65,536. When the 65, it will count up to 65,536, this timer overflow flag will be set, and this condition will be going to wrong, and it will come out to the while loop, and tf0 equal to 0. Once again we need to use timer, so I'm resetting the timer flag, and it go back to the here, and it will continuously execute 100 times, so that we get 1 second delay time here. Once the 100 times is completed, it come back to here, and it will set one more time high, and again it goes to the timer 0 delay, and the delay program will come here. So it will continuously execute it. It will generate a PWM pulse, like 66% duty cycle it will generate. In my next video, I will show how this code will work, and with the ISIS skill debugger, we can measure the exact delay is coming or not. Okay, I will. Here is the code is there, and I created already in my program, just rebuilding the program. 0 errors and 0 warnings. Go to the debug and start and stop debug. It is okay. Reset. This is the port 1. It is initially it is a high. Now I'm going to execute as a step by step. Port PWM, it is set as a low. Now go to the timer. It is a initially it is a 13-bit timer. Now I'm changing to 16-bit timer. Now it is showing as a 16-bit timer counter, and now I'm here we can see TS0 TL0 values 0 0. Now I want to load these values into TS0 TL0. just click on two times. Here we can see D8 and F0, and now start the timer. Click on to the next. Timer is started. Timer is started here. Timer is started here. We can see, and this while loop is continuously executed. So I just want to go to the run. It's counting is increasing continuously, and it will every 1 second it will turn on, and every 1 second it will off, and every 2 seconds it will on. How can we know exact the delay? Just stop this and restart. Go to the here we can see the timer is starting at 0040 microseconds, 404 microseconds. Just step out control. No, okay, execute. It is already PWM equal to 0, so and just step in. It is setted. How much time it take as a 1.00200 seconds. So it is almost 1 second. 1 second it will be turned on, and go for the next F11 and step out of loop one more time. Here we can see 1 second is completed to turn off, and just execute. Now it is going to high to low, high to low. It is a now it is a 3 seconds. That means it is a 2 seconds on and 1 second off. We can generate a 60% pulse width modulation by using this program. In ISS debugger we can see, just I connected a port 1.0 to the CRO probe. Stop the close this one, stop it, reload the add remove source file. The exe file is loaded to the this microcontroller, and click on OK and click on execute. Just 1 second. Okay, just right click here and go to the digital oscilloscope, and this is the our pulse. I want to here we can see the pulse width modulation, how it will generating, and we can measure the delay also. This I'm putting a cursor on this position. It's showing a 1 second, and 1 second off, and it's 1.99 seconds. That means around 2 seconds exactly. uh, 2 seconds it will turn on, and 1 second it will turn on. That means the total duty cycle is